you find this might be interesting, I would really appreciate if you were to take part in it, because it would help me greatly. So, thank you.
Okay, thanks very much. Thanks, Jessica. So as Jessica said, we will put a link on Blackboard, but we will also send an email around, so you get an email from us probably today where you know about that. And it would be great if you would participate. Okay, let's get started with today's lecture. We have a little more content today, so stuff that I didn't manage to talk about the last time, so I want to come back and talk about dispersion. But then on the top of that, as I said, I want to start actually with some revisions today. You gave me something to think about, and hopefully I can answer some of your questions. And in that context, then I also want to talk about exam particulars. And on Wednesday we'll have another review session. On Wednesday we're actually going to have, in our last lecture here, we'll have another big quiz. So bring your phone, bring your computer, your tablet or whatever and so on. There's going to be another revision quiz, where you can see how you're dealing with things so far. Okay, so let me talk about dispersion, or what we mean with that. Now we are in the context of analyzing the data that we have. Right, and this is sort of like the initial analysis that you can actually do, and we talked about measures for central tendency. And these measures for central tendency, they are basically summary statistics or descriptive statistics, where we want to know, can we maybe describe the data set with a few key numbers. And measures of central tendency, I introduced the mode, the median, and the mean. The mode is for nominal data, the median is for ordinal data, and the mean is for data that is either interval or ratio scaled. Right? So these are sort of like measures for finding what is sort of the middle. If I would ask you a guess about what is the weight of a cow, and I get sort of like, what is sort of like an average guess? That's sort of like, what is the central tendency of that data? Okay, that's the stuff that we talked about the last time. Today, we're going to extend this, and now we're going to talk about measures of dispersion. And that's basically an attempt to describe the variation in your results. Right? So you can, as you will see, you can have two groups with the same measure for central tendency, but in the one group you have a much wider variation than in the other one. And that's basically dispersion in a nutshell. You try to get, is this wide or is it small, this interval where you find the observations. So dispersion refers to the way values are spread around the mean, or the median, or the mode. Are they all clustered together around that measure for central tendency, or are they far away from that measure of central tendency? Maybe it helps you when you give you an example. Let's say we would have had two groups, two teams. I could have split the lecture theater in group A and group B, and then I get, people do some quiz, or they answer some questions and so on. And for both groups, I get an average score of 81.5. You'll see in a second what I mean then, or where this is going. So here the averages are the same, but can we assume that in both groups that students did overall the same on the exam? Or you could say the average is the same. But maybe in the one group, there were a couple of people that were really good, and a couple of people that were really bad, while in the other group, everybody had 81.5. That's the difference. That's the difference, and that's sort of like where measures of dispersion come into play. And now here I have a little example. This is sort of now like hypothetical plots, results, for the two groups. Well, these are hypothetical groups right now. There's group or team A and team B. At the bottom, and these dots, they stand now for people having a certain amount of points scored in this test, whatever that is. And here the test scores go from 55 to 100 or whatnot. And you see in the plot above, there are more dots, more observations, people in the middle. So when they're stacked on the top of each other, that means that two people had a score of 80, for example, or two people had a score of 85. While in the bottom graph, you see they're much further away. So there's one individual with a score of, 57, but there's also some other individuals with a score of 97. If you would calculate the average, or the mean, which is the same here, the average, for these two data sets, for these two groups, you would come to the same score. You would get 81.5. But obviously, there's a difference here, right? And that's sort of what we try to get to. So the average does not tell us anything about the distribution, that's what we call how this is distributed, or the variation of grades or scores or whatever you are measuring. So we need to come up with some way of measuring not just the average, but also the spread of this distribution. We also call that variation. And what we use for that, these are measures for dispersion. So in the same way as the last time I introduced a couple of measures for central tendency, I'm going to introduce actually 2 measures of dispersion. So what would be the simplest way to get hold of that? Now to think about, are they far away from each other or are they close to each other? Well, a pretty straightforward way would be to look at the biggest and the smallest. Where is sort of like the person with the highest score and where's the person with the lowest score? And that's actually what we call the range. So you see these terms, they are actually very simple to understand. It's really about, okay, what is the difference between the largest and the smallest observation that you have? And that's the range. Let's do that. Okay, now you see the range at the plot above, it's much smaller than at the plot below. And now I could get a number. I could just take the difference here. I don't know. I don't have the numbers, but it ranges from, let's say, from 72 to 90. So it's about, 18 probably. While in the bottom case, it goes from 55 to almost 100. So it's maybe around 40. Yeah. So now I would have my measures for central tendency, which would be both 81.5 in both groups. But I could also have a measure of dispersion, in this case the range, which would tell me that in the team A, they are more closer together than in team B, where they are further away. Yeah? So the range is defined based on the highest and the lowest score that you have. This is the range. You say, okay, the range is cool. We use the range. When I write a paper, sometimes I report the range if I want to describe a data set in some ways. But it's not perfect either. There are some problems with it. So what is the problem with the range? Now we're looking at the highest and the lowest score. Well, look at this case, for example. This is now, again, sort of like a distribution. Now they have some scores ranging from 0 to 30, and the dots, again, stand for observations or individuals that I would have asked something and so on. And when I stack them on the top of each other, that means that more people or that many people had that score on whatever variable that I'm looking at. When you look at this graph, when you look at the range, well, the range is actually massive here, right? It goes from 4 up to, I think this is 27. While most of the action is actually in the middle, right? So here's the average, and this is the range. But as you see here, most of what actually happens, most of the values are in the middle. Yeah? So now actually I could have another distribution where those values are really spread out, and the range would be still the same. Because it just looks at the highest and the lowest score. So ideally what we want to do, we want to get to a measure of dispersion that kind of takes that into account. Yeah? Somehow looking at how far they are away from each other, but also how many observations are close to the middle, or how many are far away. Right? So if everybody is far away, that's a kind of a different distribution than if some are far away and most of them are in the middle. And now we are already at the thing, and this is sort of as far as it gets. Now we are already talking about the standard deviation, because the standard deviation, that's exactly what it does. It captures this, or it tries to capture this idea, or gives an answer to the question: how far away are the observations from the middle? You might have come across the standard deviation in your stats course, or you will come across that one in your second year for sure. Yeah? So the standard deviation is essentially at the end of the day, you have your data set and you have a variable with, I don't know, where people scored or certain numbers. Think about the example of where you scored on, I don't know, what's the weight of that cow that I showed you. I can show you a distribution around that. But now you want to get an idea about how far away are people from the middle. And then the standard deviation is a measure for that, or it's the most commonly used measure for that. And if the standard deviation is large, that simply means that, that the numbers or the observations that you have, they are spread out from the mean, so they're far away. But when the standard deviation is small, that means they are close together, regardless of the range. That's sort of like the key here, because the range is always kind of like big when you have a high maximum and a low minimum. Yeah? Then the range is sort of the same for all of the regardless of all the other observations that you have. But the standard deviation actually looks at each single observation. And practically what happens, it looks at each single observation that we have and looks at how far away is that from the mean, from the average. Yeah? Each single one. First you calculate the mean, measure of central tendency, and then for each of the observations that you have, let's say I would have done this with you guys, so for each 500 of you I kind of look at how far away are you from the average guess. Maybe some of you are 10 kilograms higher, others are 20 kilograms lower, others are wildly overshooting. Somebody says 2,000, yeah? The average guess is 500, is like 1,500 above the average. Somebody wildly undershoots, says 50 kilograms and so on. So, but I would look at the differences between each and single observation and the average. So here I have now an example. So let me walk you through that. Now, this is coming back to this fictional example that I had at the beginning, you know, with these two teams, and they scored, I don't know, on some test or something, and a quiz, yeah? And now each number here stands for an observation. So here I have like 10 individuals, and these are the numbers that they got. Oh, this could be the this would be the distribution at the end of the day in your exam. I would be very happy, yeah? Because it would mean only A's. Yeah? That would be really, really good. So, what is the first thing that I did here? The first thing is I calculated the average, 81.5. How did I do that? Well, that's the stuff that we talked about the last time. You simply just sum all of these things up and divide it by the number of observations that you have. You just take the average. Yeah, that's sort of what it is. Okay, here we are. So this is sort of like the average that we have. This is the average that we have. But, and now, the standard deviation, as I said, tries to measure the difference between each single observation to this average. So let's start with the lowest score. Now this is this one here. And you see this is sort of now the average, 81.5, and the lowest score is 72. Okay, the difference would be minus 9.5. Could also look at the highest score. Let's look at this one. It's out there. Here the difference is, this is 89, and then the difference to 81.5. There we go. The difference is 7.5. Yeah, so that's very straightforward. You have the mean, and then you look at the difference from the mean to each of the observations. Okay, and this is actually now I've just filled in the numbers here, like the difference from the observation that I have to the mean. I showed you the minus 9.5 and I showed you the 7.5. But actually we can do this for all of these observations. And luckily, I don't know, this is sort of what a computer does for you, or this is sort of what SPSS or SATA does for you in a way. So you don't have to do these things manually, but you need to understand what's actually happening here. So now the difference is being taken from each one of these. And you could say, okay, well, now we are actually close. Maybe what if I would just take the sum over these differences? It's good thinking, but it doesn't really work. Why doesn't it work? Because some of them are above 0, others are below 0. So if you take the sum over this, you would end up with 0. So that doesn't work. But at the same time, we want to get to, are these values far away from 0? It's not are they positive or negative, but are they far away from 0? Yeah, that means like are they far out from the mean? If they are all very far out, that means like the distribution is really wide in a way. But if it's very small, if most of the numbers are around 0, that means your observations are very close to the mean. So actually the way this is being solved is that you multiply these scores with themselves. And you square them. So now I showed you, for example, because what happens if I square a negative number? It becomes positive. If I multiply minus 10 with minus 10, I get 100. If I multiply 10 with 10, I get 100. Right? So that's sort of an elegant way, and this is sort of, it's often used, this trick to get rid of the minus sign, and this is sort of how these numbers come about. There's also another idea behind that, which is that you want to give a slightly higher weight to those observations that are really far out. Because you could also just say, okay, well, let's just scrap the minus sign. That would be another solution for it. And actually, yeah, there are other measures of dispersion that do that. But the standard deviation uses the square. So this is sort of now how these numbers come about. Right? If I would multiply minus 5.5 with minus 5.5, I would end up with 30.25. So this is how this number comes about. And then again, we can do this for all of our observations. And luckily, this is sort of what a computer program does for you. And now you see, now we only have positive numbers. And now we have numbers that are sort of basically high when that observation is far away from the average, and the number is low. In this case, for the score of 81, obviously that's very close to our average of 81.5. That distance squared is very small. It's 0.25. Okay, we are almost there. So this is sort of like a procedure of getting to this standard deviation. But what I really want you to get is get the intuition behind that, sort of what's happening here. Yeah? You really want to understand how far away are these observations that you have from the average score over all of the observations. Because ultimately you want to know how spread out are these things. Yeah? Are they all clustered together around an average, or are they far away from each other, but they still have the same average? Okay, the next step, almost there. Now we take the sum over all of these things, and we divide it by the number of observations minus 1. Yeah. And then lastly, one step, we take the square root of that. So, but this is the standard deviation. This is the standard deviation now for this one group. But the key, the core idea is, don't worry too much about this, the sum and the dividing part and the square root at the end of the day. The key element that you should get is that if these distances are large, if an observation is far away from the average score, these numbers are large. At the beginning, some of them are largely negative and others are largely positive. If you take the square of that, they are all very large. Right, the negative sign disappears. And then if you take the sum over that, this sum is very high when all of your observations are far away from the average. While the sum is very small when all of your observations are very close to the average. And the dividing by the number of observations, that's just a way of normalizing for the fact that if I would have done that, instead of 10 people or 100 people, the sum would be naturally higher. Right? Just because you have more observations that you're looking at, in a way. So that's sort of why this divided by n-1 comes into play. And then the square root, to be honest, one could just live without the square root as well, but that's sort of just how it's being defined. Yeah. Okay, and this is the standard deviation. So now let me do the same thing for the second example that I had. You remember I had this team A, where the observations were a little clustered together, and I had team B, where the observations were a little further away from each other, but they both had the same average. They both had 81.5 as the average score. And this will be now, these are the hypothetical number for the second case. You see now the spread is much wider, and probably this is how your exam is going to look like. I hope that some people get almost full points, but there might be some people that get low points too. Let's do the same procedure. How does it look like now? Same thing. First I take the difference from the average that I calculated before, which was 81.5. Now I get different numbers. Now I square these numbers, and now you already see that the numbers, I don't know, they are much higher, right? Well, because these points are further away. They are much higher. Then I take the sum over this. It's a much larger sum. I divide it again, in this case, by n minus 1 by 9. Take the square root of it. Then I have a standard deviation of 15.91 instead of the 4 point something that we had before. Right? So now when we go back to our original two cases, this is sort of, you see the plots, how it looked like at the beginning, and both of them had the same average score. Now that was our measure of central tendency, the mean. But now you see they have different measures of dispersion. They have different standard deviations. Well, the one has 4.88 and the other one has 15.99, which now gives me an idea. That's sort of like a number to describing exactly that thing, that in the one case they are further away from each other, while in the other case they're sort of more clustered together. Okay, so that's measure of dispersion, but we'll hear more about that, but I think the intuition behind that is actually relatively straightforward. Okay, so much about the content, guys. This is sort of as far as I wanted to get with you. Yeah? So I think we reached the finishing line. So what I want to do now with you, now I want to start a little bit with revisions, and we'll continue doing that on Wednesday. And then I also want to talk a little bit about exam particulars, just about some practical stuff. Okay, revisions. So, I asked you a question the last time, and it's always interesting to see what you guys seem to care about. Yeah. So a surprising amount of people asked about beard maintenance, Maybe this is just the thing nowadays, and how long it takes to grow a beard like that. Seriously, I have this beard for the longest time, I had this beard long before it became cool. So this is sort of the thing, a serious advice that I can give you: just stay true to yourself. Just be who you are, and if you're lucky, at some point it becomes cool. So that was one of the things that you guys asked me to do. There's another thing. So, and I think it's important to take this very serious. Yeah? So a lot of people asked, I should summarize everything. A bit here, a bit there. Right. Somebody missed everything. So I was thinking very hard about what can I do about this. And I don't know, I have 1.5 lectures left, which is maybe just an hour. Yeah. How can I summarize everything? So I thought very hard about that, and then at some point I had an idea. Yeah. So I had an idea, and in order for that idea, I want to show you something. you know it. You asked me for it. But no, seriously, I think we covered a lot of ground. You do have all the slides, you do have all the videos on YouTube in a way, so use that, right? Jump back at that. There are actually no excuses in this lecture. And so all the readings are there, all the videos are there. And I think you can be proud of yourself as well if you kind of went through that and did all of those kind of things. It is a lot of material, I'm aware of that, right? But that's what you're here for. Okay, a couple of other questions. So, a lot of people ask me about the exam questions, about the specific exam questions and so on. So, what's coming up in the exam, the stuff that is coming up in the exam. So let me give you the exam questions. Oh, I'm kidding, yeah. I can't give you the exam questions. But if you paid attention to the courses here and to the lectures, I think the exam should be very straightforward. What you can do, I put this up on Blackboard. I hope that you guys had a look at it. I put up an exam preparation guide. It's in the syllabus. So in there I give you a very specific instructions. It's a manual about what you should do and how you should approach this exam. And actually in this exam preparation guide at the very end, there are a couple of example questions as well. And so these are example questions. So these are not exam questions that will happen, although there might be a chance that some of them are in the exam. I don't know. But there's a very good chance that there are other questions that are not in that list as well. But it should give you a good feeling for what is actually about to come. So if you study and if you look at those questions at the end of the exam preparation guide, if you look through the exam preparation guide in detail and do what I tell you there and have an answer for the question at the very end, you are well prepared for this exam, no matter what's going to come. Yeah? So that's sort of an instruction guide for you guys to make sense out of this. Okay, I will come back to some more substantive revisions on Wednesday, but I think it's important that you guys know what's going to happen. I also want to talk about some exam particulars now. Because some people, sometimes you just show the exam, you don't really know what is coming or what to expect and so on, that freaks you out, and because of that you lose points, right? And I don't know, nobody wants that. You should not freak out about the whole exam. As I said, I want everybody to score an A in this class. That would be perfect. I would love that. But you have to provide the right answer for that. Right? But in theory, there's no reason why you shouldn't score an A in this class when you study hard. Okay, this is the exam. This is actually how it looks like. This is what you're going to see at the end of the day. Yeah, there are a couple of things there that I want to talk about. But first of all, the most important thing, stay calm about this whole thing. That's an advice about all the exams that are going to come at some point. Now, some people are better in this than others, but really staying calm, that's already half the battle. If you enter the exam being prepared, you have no reason to freak out, right? So don't do that to yourself. Just prepare for the exam, and then it's really just about spitting it out, about writing all the things down and sort of giving me something that I can assess so that I can actually know that you actually know what you're talking about. Yeah. But stay calm and one thing after the other. So even if there's something that is unexpected, don't freak out. Okay, you will have to answer 4 questions in the exam. 4 questions. And by 4, I mean 4. You will have 6 questions to choose from. You will have to answer 4 out of these 6 questions. So there is a bit of a choice, right? But you will have to answer 4. You don't get extra points if you answer 5 or 6. We're just going to assess 4 of the questions. And actually what's going to happen at the end of the day, but I'll talk about that in a second when I talk about grading. At the end we're going to split that up with me and the tutors, because it's just a shitloads amount of exams, it's just lots of stuff. And at the end, each one of us will be responsible for 1 question. So every person who answers that question will be graded by the same person. So there will be no differences. There will be no, I don't know, I got this person to grade my exam and the other person got that person to grade the exam. That's just not going to happen, because one person will grade one exam on each and every single one of you. Which is actually funny, this is not, maybe this is because it's a research methods class, because it's one way of dealing with that problem. In research, we would call this intercoder reliability. What happens if you have different people coding something? Yeah? So then you could say, okay, well, you try to find an overlap between, what do they do? Yeah? This is sort of one way around that, because we don't have different people grading the same question. Okay, so 4 out of 6 questions, this is sort of what you have to answer. You have to answer each question on a separate answer booklet. Now you're familiar with these kind of things. Why? Well, because we're splitting these things up, right? So if you don't do that, that makes our life incredibly difficult. Yeah? So one answer for one answer booklet. But on each and single one, write your name on it, your number, and so on. You have to do that anyway. Yeah? But also clearly specify the question on it. Okay. So each question, answer each question in a separate answer booklet. I already said that. Write your name, your student number on each of the answer booklets. And if you need more answer booklets, ask the invigilator. So they will have. We told them that, I don't know, they have to expect that, so they know about it, and they will have enough of these booklets. Okay, let me talk a little bit about grading. So how it's going to work at the end of the day, and it's going to be very transparent. So we'll have a very clear, I don't know, system for where you get points, for what you get points for mentioning this, for not mentioning that, and so on. Right? So when you get a question, really read the question. If there's something like A, B, and C, then you have to answer A, B, and C. Right? If there's something, let's say, give 2 examples for each this, or 4 examples in total, you have to provide these examples, because this is really just how we tick the boxes. Did the student give 4 examples? If you only give 3, you're going to lose points. If it says describe in detail, describe in detail. Yeah? We cannot give you points for anything that you didn't give us. Okay, for each of the questions, well, first of all, the questions will be weighted equally. And for each of the questions, you can get up to 25 points, including 5 points for overall quality of writing and structure. So writing is important. So if you write sloppy, you will lose points. Well, if you write properly, you will gain points. So provide us information that we can actually give you good points for, right? So I haven't completely decided about it yet, but probably there's going to be an opportunity to gain extra points as well. If you provide something that goes far beyond what you were asked to answer, you will be rewarded for that. Okay, but when you answer these questions, well, also keep in mind that we need to read it. Yeah, and seriously, this is like the easiest way to put me off. Yeah? Just give me something that I can't decipher, and then I think, I can't be bothered with this. Yeah? And then I don't understand the word, and then I cannot give you points. So write in such a way that we can read it. Yeah? Don't write in a crazy language. Yeah? Write in English so that we can actually understand it. Okay, let me talk a little bit about the timing of the whole thing. So it says it's a 2-hour exam. Yeah, you have the date has been communicated to you, it's a 2-hour exam. So make sure that you have on top of your time management. In theory, the 2 hours should be plenty. So don't freak out if you finish early. Should be plenty. But keep an eye on it. Yeah? Because that would be really bad, and it happens. I've seen it happening. That great students, they kind of have a lot to say, but at the end they only manage to answer 3 questions instead of 4 because they're running out of time. And then I can't give them, even though they score perfect scores on the other questions, I can't give them 25 points. So that's sort of like an easy way of losing points because there's nothing there. There's no 4th question. So even if you don't know anything about a question, try your best to give us something that's still better than giving us nothing. That's just in your interest. Okay, so lastly I have another thing. If you have some more questions around the exam, so take your phone and maybe I can address it then on Wednesday. And on Wednesday I will try to revisit maybe one or two of the things that you mentioned the last time, substantively, but we won't have the time to cover all of it. But what we will do is another quiz. So bring your phone, your tablet, or something. Seriously, are you listening to what I'm saying? I'm doing my best here. Do you need a reference? Well, if you can reference, yeah, that's great. But you don't have to. That's one of those things where you will get extra points. How much do you need to write per paper, per question? Well, I don't know. I might regret saying that, but as much as you can, because that's sort of as much points that we can give you for it, right? While keeping your time limiting keeping that in mind. But if you fully answer the question, so I don't have a problem with giving somebody full points when it's a small paragraph either. If everything is in there, that's fine. Yeah. But if you provide us some more, there's just a higher chance that we find some points in there. So what you can think about, you have 2 hours to answer 4 questions. So how much can you write? You have half an hour for each question. So for some people that's a page, for some people that's 3 pages, some people that's 4 pages. I remember I was one of those students, but maybe I was just too eager. I think I wrote in one exam, seriously, this is not what you need to do. I think in one exam I wrote 40 pages. Yeah. But look at me. I ended up being an academic. Yeah. What style? Essay style? Yes, it's going to be essay style. Ethnography on paper? I don't understand that question. Yes, it should be in essay form. Yeah. It should be in essay form, but at the end of the day, you will get points for these different things, right? So if I say 4 examples, you will get 1 point first example, second example, third example, and so on. Okay, I'll have another look at this. And why am I not surprised? Okay, so for Wednesday, please have a look at the exam preparation guide if you haven't done that. It might answer some of your questions that you have here. Bring your phone and we'll have another quiz. Okay, thanks guys.